Yes, hi everyone. So, welcome to Power Systems 2 online series. And today, let us we discuss about bus admittance matrix. And before going to this topic, so let me introduce what do you mean by bus? Yes, what do you mean by bus? So, generally, the bus in the sense, so we used to, this is one element, so which used to take the passengers from one place to another place like this. And here also, the meeting point of various components in the power system is called the bus. That is, the element which is used to connect one component to other component, that is the bus. So, in some cases, the bus is also called bus bar. Bus is also called bus bar. Yes, what is bus bar in the sense bus or bus bar? So this is a conductor which is made up of either copper or aluminum, so which offers the negligible resistance. So the bus bar will have the zero voltage drop. So when it conducts the rated current, suppose for example, this is one point and this is another point. Between these two, so we connect one conductor. So this conductor carry the power. So hence this is called the bus or bus bar. Yes, bus or bus bar. And this bus bar offers the zero resistance. So when in the sense when it is carrying the rated current. For rated current, yes, it offers the zero resistance. Zero resistance. As the resistance is zero, so hence the voltage drop is also zero because the voltage drop in the sense V is equal to IR according to the Ohm's law. When the power system is represented by either impedance or reactance diagram, it can be considered as the circuit or network because we are representing the impedance or reactance diagram in a network fashion. Okay, so the bus can be treated as a node in such cases. Suppose, for example, this is one single line diagram which contains this is one generator G1, this is another generator G2. So here I have one transformer and this is one transmission line, one transformer again, and here I connect the two loads, one is motor and another one is load like this. Okay. For this case, so what is the impedance diagram or reactance diagram? For example, let me draw the reactance diagram. Or yes, first let me draw the impedance diagram. So generator can be replaced by generator resistance, generator reactance, and just wait one second. Generator resistance, reactance, and this will be voltage which is generated by the generator 1. So EG1. Next, similarly, this is for EG2. Yes, okay. Yes, these two are connected here. Therefore, I place like this. And after this, I have one transformer. Transformer can be represented by transformer per unit resistance and per unit reactance. Next, this will be transmission line. The transmission line also resistance and reactance. And again, this is one transformer, resistance, reactance. And again, here I have one motor and another load is there. Motor in the sense like this. So, which will be ground like this. Okay, resistance, and yes, here you may have the doubt, sir, how I can differentiate the motor and generator in the sense, in the case of generator, the direction of current is like this. Here also like this. But whereas in the case of motor, this will be in this direction. Okay. So this is back EMF of the motor. Let it be EM. Similarly, load. Load can be characterized with load resistance and load reactance. So here also the flow of current is like this. Okay, now how the various components are interconnected here in the sense. So first this one is generator 1 and this is generator 2 and this will be the transformer 1. Okay, and this will be the transmission line, and here it is transformer 2 again, and this is the motor, and here it is, this will be load like this. Okay, now what you can see from the single line diagram, if the single line diagram is given, if you draw the reactance diagram or impedance diagram, that will constitute a circuit or network. So wherever the node is there, that node is called the bus. This is one node, this is called the bus, and here also you have the node, this is called the bus like this. Okay, so therefore what you can say, the buses can be treated as the nodes, and the voltage of all buses, that is node, can be solved by either whatever we have the node analysis technique, that is KCL, by you can apply the KCL. As for example, here I will explain how to construct the admittance matrix from the given this impedance diagram or reactance diagram or single line diagram, whatever it may be. Okay, yes. Yeah, the first one is, let us we assume that there are n number of principal nodes are there in the network, capital N, principal node. Yes, principal nodes. So what is the difference between principal node and ordinary node? The ordinary node in the sense, for example, if I connect the resistor R1 and inductor like this is also node. But in this node, how much current passing through the resistor, the same amount of current passing through the inductor also, because these two are connected in series. So hence what you can say in the sense, this is the node, but this node is used for the to add the two components only. But here if I add one capacitor also like this, then what happened? The current which is flowing through the resistor is not equal to current flowing through the inductor and capacitor. Yes, because what is the reason behind this? So here the current is dividing like this. So hence here I can say, wherever the current is divided, the point or node, that node is called the principal node. Where are the node where the current does not divided, such node is called the ordinary node. Yes, at the ordinary node it is not required to apply the KCL. Only at the principal node only we can apply the KCL. Okay? Yes. Yes, here my assumption is there are n, capital N, number of principal nodes are there in the network. Yes, principal node in the sense, as I already told you that the principal nodes are meeting the points of more than two elements. Yes, since the voltage of the node can be measured only with respect to the reference point, one of the node is considered as the reference. So now the network will have the n minus 1 independent voltages. Okay. So because the ground has to be taken, or reference node has to be taken. So hence n minus 1. Okay. Then in nodal analysis, the independent voltages are solved by using KCL equations. Yes, now we are going to apply KCL for n minus 1 nodes. Yes. So before going to apply the KCL to the network which contains the n nodes, and out of those, so we are applying the KCL for the n minus 1 nodes. So let me assume that V1, V2, so on, Vn are the node voltages. These are the node voltages. Yes, next I11, I22, I33, so on, INN. Yes, these are the sum of current sources connected to the nodes 1, 2, 3, so on up to n respectively. Yes, what are these? Sum of current sources. Sum of current sources. Sum of current sources in the sense, so the current which is injected at the node. The current which is injected at the node. So these are for first node we are connecting I11, and the second node I22, third node I33, similarly nth node INN, like this. Okay, next. The next one is, so here what is YJJ? Yes, YJJ in the sense sum of admittances connected to the node J. Yes, what is IJJ? Sum of admittances connected to the node J. For example, this is one bus, and for this bus, so there are n number of admittances are there, like this. This value of admittance is minus j 0.1, and this is minus j 0.2, and this is minus j 0.3, like this. What is yjj? This is if it is jth node, then yjj is equal to minus j 0.1 plus 0.2 j plus j 0.3. Then how much this value? 0.1, 0.6 total, that is minus j 0.6, minus j 0.6. So this is the sum of admittances connected to the node j. This is the actual meaning of sum of admittances connected to node j. Okay, do you got this point? Yes. Next one. What do you mean by yjk? Here I used to take one more element, that is yjk. Yjk in the sense it is the negative of sum of admittances connected between node j and node k. So here I assume that yjk is negative of sum of admittances connected between node j, node k. That means, for example, this is node j, and here I have, this is node k. In between these two, I have the admittance of minus j 0.2. Then I used to write this as yjk is equal to j 0.2 simply, because I assume that yjk is negative of sum of admittances, negative of sum of admittances connected between node j and node k. Okay, then what about the equations? If you apply the KCL at nodes, that is n minus 1 nodes, then you have the equations as That is, we know that if you apply the KCL, you will get I is equal to Vy. That means y111 V1 plus y12 V2 plus y13 V3 plus so on plus y1n Vn is equal to I11. Okay. Similarly, this is for the first node. If I take the same thing for the second node, it is as y21 V1 plus y22 V2 plus y23 V3 plus so on y2n Vn. This is I22. And similarly, if I apply the KCL at node n, then it will be yn1 V1 plus yn2 V2 plus yn3 V3 plus so on plus yn Vn like this. This is equal to INN. Yes, now here if you observe, this equation contains n number of equations, and you can write this equation in terms of matrix as, can represent these equations in matrix as y11, y12, y13, so on, y1n, y21, y22, y23, so on, y2n, and similarly yn1, yn2, yn3, so on, yn. Yes, this will be multiplied by the node voltages, and which will gives the currents as I11, I12, so on, I1n. Sorry, INN. I11, I22. Sorry, I22 and I22, so on, INN. Okay, and we can also represent this in the form of matrix or equation like this: y into v is equal to I. Y into V is equal to I. Yes, in the power system, the Y matrix is designated as Ybus, which is also called bus admittance matrix. Bus admittance matrix. Okay, the node voltages are called as bus voltages. The node voltages are called as bus voltages. So, yes, in your syllabus, you don't have the solution of the bus voltages. So, hence, let me stop this content here. Now, let us we see, yes, let us we find, yes, so how you can find, how you can solve the given network to find out the Y bus matrix. Yes, I will give one example to you. How to design or how to find, how to determine the Y bus matrix at the given matrix, at the given system. Yeah, for example, this is one network. Yes, in the examination, you may have the question like this only. And moreover, if these values are represented by minus j, which means that he has given the admittances. If he gives the values as the plus j, that means he has given the reactances or impedances like this. Okay, this you have to remember. Yes, he has given the 4-bus system: bus 1, bus 2, 3, 4. Okay, the values are given like this. This is minus j 0.5, and here it is minus j 0.6, and this is minus j 0.4, and here it is minus j 0.4 and minus j 0.5, minus j 0.5. That means all the values whatever he has given, those are the admittances only. So now let me find out what is the size of the Ybus matrix. Here totally how many buses are there? N buses are there. Therefore, what is the size of Ybus? The size of Ybus is 4 by 4. 4 by 4. So first I want to find out what is the first row. First row in the sense first row of Ybus matrix. What are the first row elements? Y11, Y12, Y13, Y14. What do you mean by Y11? Y11 in the sense, yes, I already told you. Y11 in the sense it is the sum of, yeah, it is the sum of admittances which are connected to the node 1. Yes, it is the sum of admittances connected to the node 1. So, admittances connected to the node 1 in the sense, what are the various elements connected, or various admittances connected to the node 1? You can observe that here this is 1, 2, 3. So, hence I can write y11 is equal to minus j 0.5 minus j 0.4 again minus j 0.4. Then how much this value? Yes, how much this value? Minus j 1.3. Minus j 1 point. This is y11. Then how you find y12? Y12 in the sense this sum of or negative of sum of admittances connected between node j and node k, or node 1 and node 2, like this. Yes, y12 is equal to negative sum of admittances connected between node 1 and node 2. No, between node 1 and node 2, how many branches are there? Only single branch is there. That is this value. So hence I can write this as minus negative minus j 0.5. This will be j 0.5. Positive will come. Okay. Similarly, what is y13? Right, all these things. Y13. Yes, y13 is equal to between node 1, node 3. Which element is connected? This is connected. That means I can write this as negative minus j 0.4. This is j 0.4. The units are mo. J 0.4. Yes, okay. Next, similarly, what is y14? Yes, so why 1 4 in the sense? Between node 1 and node 4, it is J 0.4. Okay, so now let us we construct the Ybus matrix with all these values like this. Just to do for node 2 and node 3, node 4 also. Then let me write the Ybus matrix. Therefore, yes, Ybus is equal to node 1, node 2, node 3, node 4. Yes, here also node 1, node 2, node 3, node 4. Okay, so first one 1 1 1 1 in the sense already we calculated what are the various elements connected to the node 1, J 0.5, then 0.4, and this one 4 4 8 8 5 13. That means J 1.3 minus J 1.3. Next, between 1 and 2, 1 2, so J 0.5 is there, J 0.5. Okay, for the mutual you need to multiply with the negative. For the self elements, so don't multiply with negative sign, just to add as it is. Okay, next 1 3 1 3 in the sense 1 3, so it is J 0.4, J 0.4. Next 1 4, J 0.4 only. Similarly 2 1, yes 2 1, this is 2 and this will be 1. So between 2 and 1 we have 0.5 J, J 0.5. Next for the 2, there are two elements are connected, 0.5 0.6. That means minus J 1.1. Okay, next 2 3, 2 3 in the sense J 0.6. Next 2 4, 2 4, there is no element, so hence it is 0. It is 0. Yes, next from 3 1, 3 1 in the sense 0.6, sorry 0.4. Next 3 2, 0.6, J 0.6, and 3 3. Yes, what are the various elements connected? 0.6, 0.5 and 0.4. 6 4 1, 1.5. That is minus J 1.5. Okay. Next 3 4. It is J 0.5. Next 4 1. 4 1 in the sense 4 1, 0.4. J 0.4. And 4 2 0. 4 3, 0.5. 4 4. Yes, what is that? J 0.5 is 0.4 is 1, 0.1. That means minus J 0.9. This is Y-bus matrix of given 3-bus network. Okay. Suppose for example, in this network, if he want to consider fourth bus as the ground, then how you can eliminate the fourth bus from the given network, as well as how you can find out the Y bus matrix after eliminating the fourth bus. We will see this in the next session. Yes, okay. And moreover, what are the properties of Y bus matrix? From this matrix, what you can observe? Tell me. From this matrix, what you can observe? Hmm. Yes, here the first thing is all diagonal elements mostly negative values. All diagonal elements mostly negative values. Okay, and off diagonal elements are symmetric. Off diagonal elements are symmetric, and you can observe that diagonal elements have the more value compared to the off diagonal. So that means you can say the diagonal elements are dominating the off diagonal elements. Diagonal elements are dominating the off diagonal element. And here this Y-bus matrix is a sparse matrix. Y-bus is sparse matrix. Yes, what do you mean by sparse matrix? A sparse matrix in the sense it is a matrix that is comprised mostly zero values. mostly Mostly zero. Suppose for example, so in this network I have drawn the various elements like this, but it is not like this in general. So it may be different. Suppose for example, the network may contains 18 buses, 18 buses, and out of this 18, 12 zero values may be there in the matrix. So then it gives the matrix is a sparsity score of, that is 13 by 18. That means it is nearly 72% like this. 72% like this. So that means what you can say, sparse matrix in the sense the matrix which contains more zeros compared to the non-zero values, then it is called the sparse matrix. Sparse matrix. Okay. So like this Y-bus matrix is sparse matrix. Okay, thank you for listening this. Just to take some more examples from the textbook and solve all those problems and write on the Y-bus matrix. And if you have any doubts, just you can contact me in person. Yes, thank you.